You are the pioneers, with your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process Fellows.
So, welcome everybody to this today's webinar. My name is Jürgen Schmid, and I will give you a very quick introduction before my colleague Timo will take over the responsibility of this webinar and present the content. So first of all, this webinar is today about the harmonization of standards in automotive development, and it's really discussing the combination of automotive SPICE, ISO 26262 and ISO 21434. Before we really start, I want to give you a very brief introduction to Process Fellows. So our portfolio is presented on this slide. Basically, we are dealing with all kind of process support, process development, like the name of the company is already indicating. So therefore, we deal with organizational change, with process development, process improvement. We are dealing in the automotive industry, especially with automotive SPICE and topics like Squirrel. Or if it's about project management, HR methodology, and we support our customers as well with introducing application lifecycle management tools. We offer as well services, and services are actually about consulting, coaching, assessments, trainings, about systems engineering overall, but as well about those topics which are presented in this webinar. And this includes, of course, as well cybersecurity and functional safety. I already was highlighting the key services we are offering. So here on this slide, on the very far left side, we typically start with a kind of gap analysis. After we have identified, for example, the room for improvement, we can support as well you with certain consulting or as well coaching in the real projects which are ongoing in your organization. And in addition, we offer as well training services. After all of this kind of consulting and coaching is done, maybe after a certain milestone, you want to achieve a formal certification or kind of confirmation that you met your goals. And this is when the assessment comes in again towards the end of after a certain milestone in the consulting. Besides these services and the portfolio, the topics, we just released a couple of months ago a new website. Maybe you already heard about it. It's called spiceforecast.com. And actually, we map their so-called knowledge nuggets to the practices which are defined for these SPICE models. So, for example, on spiceforecast.com, you find the automotive SPICE 4.0, you find the automotive SPICE for cybersecurity, the potential analysis, and the mechanical SPICE. And the key advantage of this website is really that there are so-called knowledge nuggets mapped, and they support as well how to implement those practices, for example. It's for free, by the way. Here on this slide, you're seeing the next few upcoming trainings. So just next week, we will do a process expert training. It's guaranteed. So we have quite a lot of participants for this. We have as well a guaranteed upgrade training towards the end of January, so January 22nd. And in the next couple of weeks, there will be as well a provisional assessor, a SPICE for mechanical engineering. By the way, Timo is as well our instructor for mechanical SPICE. Then we have another training about machine learning, end of February, and another training about potential analysis as well, end of February. For both trainings, there's still an early bird discount available. Of course, we have further training dates on our website. Here you see the URL, so please just visit our website if you are interested in other dates instead of what's presented here on this slide. So, like usual, webinars are recorded. So I want to point out on this because of data protection and privacy. So if you're not agreeing with this, so please better to leave this webinar. Otherwise, this webinar will not show your name at all, right? So this will be deleted afterwards in case it's somehow showing up. But the webinar will be published on YouTube in the next couple of days as well. What else is important? So during the webinar, please stay muted to avoid any disturbances. And you should find in the Microsoft Teams a button which is maybe called questions and answers. In the English user interface or in the German user interface, it's maybe called F&A. And you should use this to specify some questions, and we will discuss these questions towards the end of the webinar. So please feel free to write down here your questions, and I will call them up towards the end of the webinar. Yeah, that's it. So for a short introduction about Post Fellows. Now, the last topic is to introduce the presenter. It's Timo Karasch. He's one of the first fellows at Post Fellows. He's a principal assessor and instructor. For example, for automotive SPICE, mechanical SPICE, like I already mentioned, hardware SPICE, cybersecurity SPICE, and even for this ISO 33061, which is a kind of a SPICE model independent of automotive industry. He's as well participating in several Intex working groups. So, for example, he's one of the co-authors of the mechanical SPICE as well as cybersecurity. And he's, of course, doing as well consulting and trainings and assessments along with these SPICE models. So, Timo, I would like to hand over to you and yeah, have fun with your presentation.
Thanks a lot. Okay, so let me switch the presentation. Thanks a lot, Jürgen, and welcome everybody to our first webinar in 2026. And I'm just opening my slides. So yeah, today's topic, Jürgen already introduced it. It's harmonization of standards in automotive development. And Jürgen as well mentioned already what kind of standards will be in focus for today. So it is automotive SPICE, it is the ISO 26262, and it's the ISO 21434, so the standards for functional safety and for cybersecurity. I will try to not only repeat all the standards, what's written there, yeah, what is the idea, the meaning of it. I will try to focus on some examples here to get it maybe more useful for you, yeah, that you can think about, hey, what is it really looking like, yeah? So to make it a little bit more interesting here. Good. Now let's really start. Let's have a look at the agenda here. Very brief introduction, because just to make sure that everybody's on the same page when we talk about automotive SPICE, functional safety, cybersecurity. So what is it all about? And then the first big topic here is this extended lifecycle approach. So everybody of you knows here, it's only a standard. It's just defining typically what is expected to be done. And we will try to have a look, how is this really looking in an organization? So if you go to your intranet page, to your tool, whatever you got for your processes, what is it looking there? How are those standards typically presented overall in your standard process in the organization? And to get a better look, we will have one really practical example here, and this will be about here. We picked the software architecture design here to show a little bit the process, the methods that are typically used, or examples, what it looks like. Please, there will be a lot of information on those slides. Because of the timing, I will just focus on the main aspects of the slides, but I don't want to here just shrink it to only pieces of information. I would like to give you the overview here as well. But if you have any specific questions, please raise this question and answers here, and we can jump back to the slide at the end and maybe have a closer look here. Or here, if you check the slides afterwards here, you know they will be published here, then you can get a closer look here as well. I'll just concentrate on some main aspects when we look in the software architecture design. Then looking briefly at the mapping strategy. So how can it be done together with the idea of automotive SPICE? And finally, looking a little bit more at the quality aspect of talking about assessors, auditors, how can you combine this in the idea of assessments for safety, security, and automotive SPICE here? Good. So let's start with this introduction just to make sure we're on the same side. For you're noticing what I'm talking about, you can see there's three circles here about automotive SPICE, functional safety, cybersecurity, even marked with a color. So if you just look at the slides on the right side, you will see those marks that you know exactly, are we talking about SPICE, safety or security here? Good. So what is the overall idea of those three standards? Start with automotive SPICE. I already looked at the list who is interested in today's webinar. I think there are a lot of experts about SPICE, so no need to go too much into detail. But you know, SPICE, it comes from the ISO 33000, and there is this definition of performance of assessments here. So SPICE really is just about how to perform an assessment. And why do I do this? Because I got some results here, and those results might be used for process improvement or might be used for the capability determination. This is exactly the name SPICE here, process improvement and capability determination. What I would like to emphasize here, especially at this slide, is please, it's not only about capability determination. I still read a lot of articles and see a lot of videos somewhere in the internet about people who are telling you SPICE is not worth it here. It's just waste of time and we're slowing down everything because they just think it's only about capability determination to show somewhere a capability level. No, especially today, please, we talk about process improvement. We want to have better processes here, to be faster, to do less failures here, and especially to have a real basic for the topics that are coming next, talking about functional safety and cybersecurity here. So please, SPICE, this is what it's all about. Jumping over to safety. So what is safety? Safety in one sentence means it's the absence of unreasonable risk that can cause harm. Here, if you're sitting in a car here and you drive and you know there's a automatic brake system, you know, okay, this automatic brake system, this should help me to save my life maybe, but you know, every malfunction may be a risk here because even every function that should save a life could harm even such a life, and this is why we talk about safety here. In automotive industry, we're interested in functional safety, means the absence of unreasonable risk due to hazards caused by malfunctioning behavior of EE systems. So it's not safety in general here, it's not walking around with a knife in your hand. No, it's really talking about systems that we use in automotive industry, ABS, braking systems, steering systems, etc., etc. To ensure functional safety during our development, we need to plan all necessary activities. We need to perform those activities. We need to check the results to make sure everything is done properly, and then at the end, act if we see any kind of deviations. This is what we call safety management. So important for us in automotive projects, we need to guarantee a kind of safety management here to make sure there is no unreasonable risk left in our EE systems. And then just one page for cybersecurity. It is very close to the idea of functional safety because security is as well a kind of prevention here, but we talk about threats caused by deliberately induced events. So means again, there can be a kind of harm or something can be destroyed, something can get lost here, but this is, as you see, this is caused by a kind of threat. So always an induced events coming somewhere from here, from the bad guys somewhere around. In automotive, we can bring it down now to a specific topic again, and this is where we talk about cybersecurity. So not security in general here, like all kinds of locks or air doors or keys or whatever. No, we talk about cybersecurity in automotive. So again, we talk about EE systems, all kinds of systems that we use in our car. And this is where we need protection or resilience against intentional attacks. So really here, the bad guys doing something. Why? Because this is here causing maybe some accidents, some hazards here. And three keywords that you should remember for cybersecurity. You maybe even know already from security overall here, if you heard about cybersecurity, about data security, about information security. These three words are confidentiality, integrity, availability. This is what it's all about here. If you have important information that nobody or not everybody should be aware of, then this information is confident. If you know it's important that this information is not lost, not changed or everything here, then it's about integrity. If you know you need this kind of information or whatever right in time, then it needs to be available. And this is attacked by someone else. So security shall be achieved during and after the development through a strategy. So continuous and prompt adaptation of the system to defense against these threats is necessary here. It's an ongoing activity. And again, compared to safety, we have again a management, and this is where we have organizational policies, rules, and processes in place as well. So this is just summing up the three topics. Just to make it clear, here's just an important one picture talking about the difference between safety and security. And maybe you saw this already in quite a simple or similar way here. So safety means we're talking about taking care of potential hazards caused by our system. So our system have a malfunction, and this will cause any kind of harm, for example. And security is vice versa here, considering potential hazards to our system caused by someone from outside. So security from outside in our system, safety from our system to the outside world. They are very close to each other, and even when we talk about some methods here, very often they reference each other. Security can influence our safety here, but shall not disturb the safety here. Better safe than sorry. If you have an automated brake system for emergency, and you know the system will not react because first of all they want to be sure whether the signal they got is really here trustable, then we are losing time that might even cost life. So no chance here, safety comes first. So why is this now a topic to us? Why do we have a webinar like today where we bring together the idea of quality of the processes, here, safety and security? First of all, we have more and more responsibility given to the EE systems in automotive. They're getting more and more complex, more and more functionality is integrated. So the systems from former times, they are here doing now all at once. We have growing complexity, growing intelligence of the systems here. There's high connection, distributed development, high need for communication, not only communication between the parts and the system, even a lot of people working together in different locations, different areas all over the world. So a lot of communication is needed. And we talk about autonomous driving here. We still dream of sitting in a car and just be driven by the car itself. So the human driver is not in full control of vehicle anymore. So we need to trust those systems here. Random systematic failure is still part of EE systems. We will never develop a system that is completely out of any potential failure. And we must always expect targeted attacks on EE systems. Sorry to say so, but there will still be the bad guys who tries to disturb something, to destroy something, and this is about security here. So this is why, we have no other chance in working on those topics. And why do we have to do this? Okay, first of all, we might have a customer who's already asking for safety and security when we talk about cost, image, loss of life. Sometimes we have even regulations coming from the law, although those ISO standards, the 26262 and 2144, they are not mandatory itself. They're just standards, and the standard itself is not mandatory, but they should be followed as state of the art, as it is called. So it means it is typically expected. Besides this, there are already a lot of discussions in the EU or even in other departments where they talk about maybe those standards need to become mandatory. You already know there are some mandatory rules even for cybersecurity if you want to place a car into market here. but the overall ISO standard, not mandatory. But last but not least, here, when we talk about, do we need safety? Do we need security? Yes, we do, because at least it should be our intention here. We're talking about systems we are using ourselves. So if you are sitting in a car, you're driving somewhere on a highway, and you hope that your system in the car will work, will be safe and will be secure, or all the systems that are in use around you are safe and secure, because at the end, it might even be your life that is here endangered here. So this is why we need those standards. Let's try to bring the standards now together in the idea of a extended life cycle approach here, bringing this together. This is the picture you know from Automotive SPICE. So we have a couple of processes defined in the reference model of Automotive SPICE, and everybody who was participating already in a training for SPICE, if you have not participated in a training for SPICE, you know where to get those trainings. But if you participated already, you learned this is not a life cycle model here. It's not telling you, yes, it's a mandatory V you have to follow. No chance here. It's just placing the activities together in processes just here to have a kind of grouping, a kind of sorting here. This is not a life cycle model. Looking at ISO 26262, we have a similar picture here. Because first of all, we have just an overview of many parts here. Here you see the parts of the ISO 26262 with its chapters here. And you see again, they try to present it as a kind of V here. But first of all, this is not a life cycle model, but the ISO 26262 comes already with an idea of a life cycle here with a safety life cycle. So this is just pointing out the important chapters here, or chapters of some of the parts of the ISO 26262 that are important for the life cycle. And this is where you see they are grouped into, first of all, the idea of safety management here, managing all the activities across the development. Then looking here at the concept phase, so that we have a couple of topics here, just concentrating on a phase they call concept, and we have the development phase, we have a production phase. But still, you see, this idea of a life cycle is a very rough life cycle. We just talk about 3 phases and addressing some topics that are mandatory in those phases. That's all. It's not giving you something like, hey, we talk about development like V model or agile development. No, this is still open here. Jumping over to the 21434 for cybersecurity, it is pretty much the same then in functional safety. Here you have the overview of the parts and the chapters here for cybersecurity, and they as well come with a kind of idea of a life cycle, but just bringing together a little bit or showing the dependency here between these topics. As you see here, this is about the development here, again talking about concept, talking about product development, talking about validation here. So it looks like a V, but you see it's in a very rough style, not going deep into real development approaches. So the standards itself are giving us just the processes here, just maybe dependencies here, not really the life cycle. So what is the same in all the 3 standards? We have a complete product development, including system, software, hardware development here. We have even management activities for project-specific development. We can allocate this in supporting activities. Important topic is supplier involvement because of the many people and companies involved in such a project. But there are important differences that are important for us for this combined approach. First of all, SPICE really just defines what is expected here. There's nothing more than just what should be done here, like the software architecture here. Specify your architecture, that's all. And it's not telling you how to do this, what kind of methods you use, what tools, what metrics, what responsibilities are there, etc. The ISO 26262 and 2144 go slightly into methods here, talking about the how, by a recommendation of important methods or practices here, as you will see in the example. So they go a little bit further here. SPICE just focusing on development here, nothing else than just pure development, but you know, functional safety, cybersecurity, they talk about post-development, yeah, especially in cybersecurity important because it's an changing system over the time when it's in use. And we have starting activities that are important. So they start a little bit earlier than the idea of automotive SPICE, the safety and security. They start with this idea of risk and analysis activities that you know from the HARA and the TARA here. So you saw both are about absence of risk here, safety and security, and this is a starting focus here on those standards. So let's try to bring this now together. And this is where I try to do this jump from what is expected by the standards to what is the reality? How is it really done in the organization? And here's an exemplary product life cycle showing the processes like it might look like even in your company. And your good process descriptions in a company are typically independent of the time, first of all, and this is why at the bottom here you see this process overview. So if you concentrate now on all the key processes that you need for the development of all your products here, then you know you have activities for system development, software, hardware, mechanical development, you have management support activities here. You already see those processes here in my example. They are not following the naming of any of those standards. Yeah? Here we talk about input requirements, for example, or we bring together activities in something like construction here, or we create a new process like test management that is maybe not mentioned in most of the standards. So the structure here, the real organization of processes in your company, this is completely up to you, up to your organization. Here it's completely free if you want to follow an idea of a standard or if you have your own wordings. And very often in most companies, it's even good to have own wordings here that are understood by everybody here who need to work according to them. Besides the description of processes, we have then the life cycle, and this is where we bring the timeline in, and this is where we have the phases and the quality gates here in between. This is where, you know, project starts with acquisition, concept phase, all the sample phases, validation, production, here up to decommissioning. And depending on the kind of project, we have different phases that we need. Maybe even phases are doubled. Here we need the checks in between. And in all the phases, more of these processes will be used. So this is an overall idea of how the reality of a process description might look like. And yes, with those processes, you could cover the idea of those standards here. I think how automotive SPICE could be mapped here, it's quite obvious, but let's have a brief look at adding now the idea of functional safety. And this is where, if you look at the top, you see the life cycle again. So this is where you can start mapping the safety life cycle with your concept phase, production phase, etc. Where you know, this is where we can add the HARA. So when does it need to be performed? Like during a concept phase, or where you can add additional activities like our safety audits here during the gates. So everything that is time-bound is somewhere added here to the life cycle. In the middle, in the gray box, we have now the development activities, and this is where we add all the safety activities here when we talk about safety requirements, safety analysis, etc. Like, and you see some examples here talking about safety goals need to be defined here at the first process. Functional safety concept need to be created. Or later, we talk about the technical safety concept. We talk about additional tests here for safety mechanism. We need to talk about activities to define redundancy in our concepts or additional diagnosis function here in the software. We need about guaranteeing of the interface to production that is mentioned here in the 26262. And finally, we have even the management support processes where we know, okay, we will have another role that is working in this project like a safety manager. We might address all the confirmation measures 26262 in our quality assurance process. And we might even have an additional process that you see here already, the safety management, that we know everything that is about planning and tracking of safety activities, all the performance of safety assessments. This is done here in the safety management. Adding those activities, descriptions, methods, etc. of functional safety in your standard process, this is as well here something that could be handled during the tailoring of a project here. If you know this project is about functional safety, then everything that is shown on this slide becomes active and need to be performed by the people that are assigned. If you know this is a project completely without functional safety, this is maybe tailored out here. It might not be necessary. But it makes sense to have it already addressed somewhere in your overall process, because some of those aspects here, they might be even helpful in non-safety projects. Here, I talked about a lot of people that were talking about, hey, this interface to production, or methods like hardware software interface specifications here. Hey, these are important aspects. Let's do it. Doesn't matter whether we are safety relevant or not. And quite a similar picture we can draw now for the idea of security here on the next page. So this is adding cybersecurity. Again, looking at the life cycle, we have this idea of security life cycle that is added here. What activities are time bound in concept phase, in development phase, or in later phases? Where do we perform the TARA? And what are the activities for post-development support, and who is responsible here during those phases? During development, we have the security activities, again, talking about requirements, analysis, etc., like talking about security goals or the security concept at the beginning, talking about additional cybersecurity controls that are important during all the architecture steps here. Talking about penetration testing, for example, a new topic that comes up somewhere in the testing, verification, validation here. Talking about interface production again, or talking about management, like a security manager that could be assigned in our projects here. The supply evaluation regarding the capabilities here, that you are not working with any kind of supplier, that you agree or try to ensure that this sub-supplier is really capable to work in cybersecurity. And again, maybe an additional process like here, the security management, talking about planning, tracking of those activities. You already see that many of those topics here are very, very similar to the idea of functional safety. And this is where we said, okay, it's not always contradicting each other. This is where sometimes some activities might go hand in hand. And this is the idea that you say, hey, let's have a standard process, first of all, here regarding our real activities with all the activities, responsibilities, and then try to see what are maybe additional activities, methods here, or results coming from safety and security that we can add over here. This is hopefully already showing you this idea. And this is what I would like to show you now in one big example. And this is where here I jump to the process of software architecture design. And I will try to give you some ideas of what might be done now in the picture of automotive ASPICE, in the context of functional safety, and in the context of cybersecurity. Again, please, there is a lot of information on the next slides. I will just focus a little bit on the highlights of the slides. If there's something that is interesting for you, here, please, put it somewhere in question and answers. Maybe we can jump back later or try to look it up, or please, you're invited, come back to me or come back to us. We would like to give you even more information here on those slides later on. Good. So this is again the picture, and you see we highlighted the process over here, talking about architecture here. We might give it a different name in our context here in our organization. And first of all, when we talk about automotive ASPICE, you know, automotive ASPICE just defines what is expected, and they expect that you have your process here, the idea of software architecture design somewhere in your project. And the purpose is to establish and analyze software architecture comprising static and dynamic aspects consistent with the software requirements. So this is just a very, very rough idea what is expected to be done in architecture. To give you a better picture here on the next slide, I will maybe give or slightly move a little bit even to the idea of system architecture here. In SPICE, this is not a problem at all. As you know, SPICE is defined the way that it is here pretty much exchangeable between all the different disciplines. If you look at software architectural design, it is nearly the same than system architectural design or activities from hardware design, from machine learning, or even from mechanical architecture here. Because what needs to be done, it's completely the same. How it needs to be done depends on the kind of discipline, the kind of product you have, the complexity you have, etc., etc. So everything needs to be done, but how you do it, this might differ here. Let's try to move it again to maybe a more practical way. So how is it looking in reality? And here is an example of such a process. This is where a company tried to create activities for software architecture design somewhere in their standard process, given an introduction to everybody. So what should be done here in our projects here? You see, this is swim lane, so means we have the roles here, the lead developer engineer, we have design engineers, we have the complete project team here, and you see in blue the main activities like, first of all, the lead engineer will identify all necessary components of the software based on all requirements architecture that are available. Then the design engineer will work on each component to specify the interfaces here and to create the design for all those components, and maybe even creating a separate interface specification here. The lead engineer is responsible to make sure the architecture is analyzed. This is where all the experts are participating here, given feedback. Then we have this formal review and approval of the architecture, again, where the participants are supporting to get a review report at the end. And finally, we want to communicate this to everybody. And this is where we have finally the agreed architectural design here. This is done together with some support, like we have design guidelines here in place that everybody knows how to define components and design. And we might have even design tools in place helping us to do this job. So this is just example. Now, mapping the idea of automotive SPICE here, we come to the so-called base practices from automotive SPICE. And this is where you see, okay, what is the expectation of automotive SPICE? Just that we specify static aspects here of the software architecture. And you see it's defined here in detail here, static aspects here based on functional, non-functional requirements, talking about interfaces already. What does it mean? Automotive SPICE is living in a very, very easy world. They're in an ideal world to make sure this can be a science in pretty much all of the projects. And this is why they talk about a very easy structure of results. So based on stakeholder requirements, you have requirements on system level, you have an architecture on system level, and then you bring it down into software, hardware, mechanical requirements, and we bring it down in software, hardware, and mechanical architecture. So this is stereotype here. This is just given some domains and just given the name architecture. But this is just the ideal world. This is not what the reality is describing. The reality might look different. So please, first of all, it's the task of everybody to map this to the reality of your organization. So what are the worlds in reality? Because here it's very generic, and in reality we are looking for maybe a document really that is called architecture, but they might call it concept, model, drafts, layouts, schematics, drawings, etc. Yeah, so the hardware development has completely different wording, like mechanical or software development, or people working on system level. So this very, very generic idea of architecture might have a different wording in reality. And this is why you see the small picture of glossary here. This is where a glossary of a company really makes sense, that everybody knows, okay, if there's someone from outside, like an assessor coming, asking for an architecture, hey, this is what we're going to show him. And here's an example of what this might look like in reality. For example, UML diagrams here with all the components. In the other disciplines, we add now additional activities like, hey, let's address this with a safety concept here, with a technical safety concept of functional safety. And as you see, this is where we map the technical safety requirements here in this part, where we have the architectural design that I just mentioned, where we have the allocation to hardware and software, and development of requirements of architecture on hardware, software level, breaking it down. So this idea is already added somewhere, and you see they are using even the words of requirements, architecture, design, but just in a slightly different context, now with a focus on functional safety. So this could be something that is added here, and this leads to a slightly different picture even. If you have this overview of components here, like I showed you based on automotive SPICE, you, for example, see these levels here, where you see, hey, look, this component is just QM rated, others are ASIL B rated, and you see the critical path throughout the complete project. And one aspect that I already mentioned is the HSI, the hardware software interface specification. This is a good example where you see the 26262 is defining not only what is expected, they go a little bit inside of the how, that they say, okay, we expect something like hardware software interface here, already giving elements that need to be described. So they go closer or deeper inside of the idea of results here or methods to be used. This is what you even see in those tables here. They come up with those kind of tables. Here, for example, the principles that should be used for the architecture, and trying to help you with a selection of those methods to say, okay, what is really highly recommended, what is very helpful for you to ensure requirements, what is still recommended, and what has no recommendation, so neither for nor against it. And then you see with this numbers here at the beginning, some consecutive entries or alternative entries, means in the context of functional safety, let's try to pick a combination of different disciplines that are helping us to ensure the fulfillment of the requirements of the 26262 at the end. So it's not really a strict must, it's more a kind of recommendation here, but most of the companies try to stick to those tables because it's much easier here. And again, this is something coming from functional safety, but is used already in many companies, even in non-safety critical projects. Let's move on to the next topic. This is now talking about dynamic aspects of the architecture. So going from static to dynamic. And this is where, this is where we have in reality dynamic views, sequence diagrams here, just giving you some examples here of what this might look like in the real description. Not always in the same document, maybe even in different documents or repositories stored. Or we have state machines that are defined here in architecture. What does it mean now in the other disciplines? And this is where we can jump to an example of cybersecurity. Means cybersecurity will add security-specific mechanisms here, such as zone of trust, interface protection, secure data, etc. Interfaces allocated to threats. And this is where, for example, threat models are used. So an additional view in your architecture is just added, very often already provided by some tools. Means we have a picture here, and this looks a little bit like a flow chart in the architecture. Here there is here a kind of function given a signal to the next element here, given the request, and then trying to do a reaction. And with this kind of view, we try to now show where do we see threats here, where it might be a manipulation of a signal here, disturbing the system, and where do we address those cybersecurity controls to ensure that this works properly at the end. So an additional activity, an additional view coming from cybersecurity, just added to the view I showed already here for the standard activities here. The next one, the analysis of the architecture, and this is here, if you look in Automotive SPICE, you have a couple of examples here, what they try to expect here. Just showing two examples here. This is where, for example, you analyzed to see the resource objectives here. So what resources are used? Do we have better alternatives here to use less resources, or design decisions where, you know, we have different alternatives, different ways to solve this problem. So what could be the best solution for us here? And here, this is adding up in make or buy decisions, for example, or the reuse of some components here in the classical development. For functional safety, during this analysis, we put the focus here on the safety-oriented software analysis. So we have the analysis on each and every level here, like here, for example, in software analysis. And you see, this is where, for example, coming from a safety plan, the idea of what should be analyzed here. So besides those aspects like reusability, make or buy, we as well analyze for any potential systematic failures or any potential random failures here. And this is by looking at our architecture to see, hey, is there maybe a potential failure, or is our system or software able in such a situation of a failure to be able to identify this and to react on this? So an additional aspect to be focused here on safety during the analysis that we do already. And the same then for cybersecurity. This is where they call it weakness or vulnerability analysis. So we can have additional cases of alternatives here, and we perform a kind of weakness analysis here. And this is where we here try to identify, hey, what kind of security controls are selected? Are they appropriate? Are they allocated to the requirements? Do we have architecture design guidelines for this in place, and to ensure the review even for those aspects here? Then consistency, traceability, making sure that all the information can be mapped to each other. This is where Automotive SPICE already comes with an idea of a traceability, like looking at the software architecture, that we know every element of the architecture has a description somewhere in the requirements. And this is comparable to the ideas that we saw in the other here. The functional safety reuses this idea of traceability, because this is the same here. Here we'll go to the software architecture design. Every component that is safety related need to be traceable to the safety requirements here. And the same even for traceability in cybersecurity. But as you see there, using very, very generic words here, they just call it design of subcomponents here. Last activity, to communicate the agreed architecture. And here, as you see already, affected parties are mentioned in here. And if you remember this mapping of the life cycle, affected parties are then not only the developers here, we have even safety experts, security experts that might be included. This was just one example where you see here, we first of all transferred the overall idea of the process to the reality. Here, if you remember the picture of our processes here, coming with a standard process of activities, inputs, outputs, and then we map the idea of what are activities that are recommended based on Automotive SPICE, what are additional activities that we could add for safety security, what are maybe methods that are expected that should be added here, or what are even results that are recommended. To come closer to the end, let's look at the mapping strategy then here. So how do we bring it together? What does it mean? It's a kind of summary already, because this is bringing it to the idea of quality now. So we have the two standards of 26262 and 21434. So both are already expecting an implemented quality management system here. So they both mention that 9001 or 6949 need to be established. What does it mean? If you work with quality management system, it's expected that you have the defined continuous improvement process and that you perform regular checks on the process usage and the process quality here. So this is why both standards come back to the idea of automotive SPICE. They mention it from time to time here as an example, but this is what really could be the benefit of automotive SPICE in this domain, that you know, hey, if automotive SPICE is guaranteeing the quality of the development process that we are using, that we do it really with purpose or with in a kind of structured approach here, then you see structured approach, usage, appropriateness of processes, or adequate process quality, then this is the basic recommendation for implementing safety and security activities. And this is where even the sentence is used that automotive SPICE ensures the idea of QM level in functional safety. So it does not mean, hey, we need to do nothing. No, quality is needed, and quality means that we need to check whether the process is used and adequate here. So they are here basing on the idea of automotive SPICE here. And this is what you can even see in the methods here. This is why you can start to combine the methods even to check the quality here, like the combination of SPICE assessment and safety audits. By the way, if I talk about safety audits, it is comparable to the idea of security here. So, automotive SPICE assessments here, checking the fulfillment of the process here, checking the process quality, and performing this based on the base practice that I showed you at the end. We have the result of the capability for each process here and process improvements. And this could be now done as well, the completeness performance of the activities for safety security based on the expectations here. And this is why this is sometimes even done together. Sometimes we really perform it together, and there is a paper that might be even helpful for you. Some people that work together within the working group for cybersecurity created a paper on an idea of combination here as well. This is where you see here, this is an example. They showed that they perform an assessment here, coming up with an assessment report, adding then the idea of safety. And here, this is just the process view here, looking for the quality of the process, and then based on this, doing the evaluation of the product for safety. And this is what ends up then really in a combined report to save some time here doing the aspects of SPICE, safety and security together. And this is here everything I wanted to show you, to give you a brief overview. So hopefully you see now the main idea of the three topics: automotive SPICE, functional safety, cybersecurity, that they are really referencing each other from time to time. And you see the idea of bringing it together, first of all, in the idea of the life cycle model inside of your organization, in your standard processes, and then with a closer look, even with this example in a standard process where you have additional activities, methods, results for safety and security here. If there are any questions, I would like to answer it right away, or maybe even afterwards, if you would like to stay in contact here. And here, if you want to dive a little bit deeper in those topics of safety and security and how this here can be done in reality together with those activities, I again would like to mention our trainings here. We have trainings for safety and security, especially for the idea of bringing it into an organization to be more efficient, that you do not only this kind of extra work here. Thanks a lot. And now time for questions.
Okay, thanks a lot, Timo, for your presentation. There are already a couple of questions available, so I would like to go through them first come, first served. And actually, the very first question I can answer, because it's an easy question. Will the presentation be shared to us? Yes. So typically it takes us something like 2 or 3 days to do the video editing of the webinar. And you can find the PDF as well, the YouTube link on our website. So just start on our homepage, and then there will be as well a pointer to a submenu to the webinars, and then you find the references to the PDF and the YouTube link. So just give us maybe 2 or 3 days. The second question I would really like to hand over to Timo, because this is really talking about the functional safety and the software architecture base practice 1. And the question is, the only adding proposed for SWE 2 BP1 is assigning ASIL levels for the software components?
No, not really. So as I told you already, it would be, I think I would be able to talk 4 hours only about the process of software architecture here to go really into every detail. So this is why I picked out really just some important examples for safety and security. What I showed you, I could jump back, were 2 topics. First of all, the idea or the parts of the technical safety concept that is addressed there. This would be a topic that is even bigger here, the expectation of what is to be included in a technical safety concept. And the second topic was this allocation of ASIL. But just 2 examples coming out of the 26262 here. There might be even more activities helpful here. Yeah.
Mm-hmm. Okay, good. Thank you. Then from the same participant, there's another question, I think maybe as well linked to the same base practice, at least to the same process. And the question is, why are you proposing weakness analysis and threat modeling for adding cybersecurity to SWE 2?
Because this is a topic that is necessary in all the architecture processes. You have it on system level, you have it on software level, you have it on hardware level. So a kind of vulnerability analysis. So you have the concept at the beginning of the project typically already, but you have just a rough idea of the architecture. And it doesn't matter whether we talk about a system architecture, software architecture, mechanical architecture. It becomes clearer during the kind of during the time of development. And this is a kind of additional activity here. Let's have a look at the architecture with a focus. Do we see any additional vulnerabilities here, like storage of data or transfer of data that we have not expected when we created the first draft? Means maybe an additional activity might be necessary here. So it's an activity done on every architectural level here.
Mm-hmm. Okay, good. Thank you. Then the next one is, I think, not necessarily a question, more a note or comment, and it's about conformity assessment procedures. I think the idea is about something like product conformity according to CE marking, something like this. And the note is the conformity assessment procedures are making the status of the art part of liability of the developers. I added in the chat, so this participant added in the chat a picture to bind the regulations with the standards as highlighted in several forms by Mr. Dr. Helming. So I think it's a legal office or something like this.
Okay, I would like to have maybe a closer look than later. Quite interesting aspect. So it is. I know functional safety already exists a couple of years, but still the companies discuss about how can we try to combine it to have not only the capability of the development process and scope, but as well the safety of the product itself. Here, what is now a mandatory regulation if you come to release later on. So there are different approaches, but I would like to get maybe a closer look then afterwards to see here what you recommended here. Maybe if you want to stay in contact afterwards, could be good to here discuss it afterwards.
By the way, was there your email address on the slides, Timo, in the beginning? So otherwise it's just timo.karasch@processfellows.de, right?
Yeah. I think it was in the introduction somewhere. Yeah, when you introduced me, I think it was mentioned. Yeah, timo.karasch. So pretty easy to find me, I heard.
Okay, that's it. Any other questions?
Otherwise, please do not forget to like the video on YouTube. I want to become the next YouTube star here. And
Okay, good. Then thank you very much, and give us 2 or 3 days, and then you find the slides and the YouTube link on our website. Thank you, and bye-bye.
thank you. Bye.
Thanks for the presentation. Bye.
Thank you. Bye.
You are the pioneers. With your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process Fellows.